welcome to The Legend of Zelda ASCII Art, Hexagonal Architecture, and You. My name is John Turner. Just a little bit about me to get us started. I'm a software developer. I work at a company called Immersion. We do automated online language proficiency evaluations. So if that sounds cool to you, go ahead and check out our website, or feel free to ask me more about it. Speaking of contacting me, I have my email address here and my LinkedIn profile. Feel free to message me, ask me questions, give me comments, stuff like that. I also put a link to the Utah Software Craftsmanship group on here. I'm one of the co-organizers of that group. So if you're interested in finding a group of people who like to talk about things like test-driven development and continuous delivery and code quality and things like that, feel free to join us. We meet on the first Wednesday of every month. Right now we're meeting virtually. So even if you're not in Utah, you can feel free to join us. We also have a Slack channel. Feel free to join that as well. I put a link here also to my personal website if you want to go check out other weird, random ASCII-based games that I've made in the past. Feel free to do that. And finally, on here, I have a link to the slides. If you want to go back and review them later, feel free. I'll also put a link to the slides at the end of the presentation. Okay. I'm going to start off by saying sorry. Normally when I give a presentation like this, I like to give sort of a little summary of what we're going to talk about. That way, you as an attendee, if you're sort of on the fence between this session and another session, you can kind of get an idea of what we're going to talk about. And if this session doesn't fit your needs so well, you can go find a different one. That's great. It's a little bit hard with this session to explain exactly what we're going to talk about without just giving the whole session. So very briefly, this is kind of an experience report. We're going to look at some code. We're going to talk about architecture. We're going to talk about Legend of Zelda a little bit. We are going to go over code. There are going to be a fair number of memes. So if all of that sounds interesting to you, buckle in. I hope you enjoy the presentation. If you're like, no, that's not my cup of tea, that's okay. I encourage you to go find a different session that you think will maybe fit your needs a little bit better. That's okay. You won't hurt my feelings. We can still be friends. All right. With that out of the way, let's get on to our presentation. Our story starts a long time ago in a galaxy far, far away. And by a long time ago, I mean in 2008, which for some of us was a long time ago. For others of us, maybe not so long ago. I'll let you decide. And by in a galaxy far, far away, I mean on a website called tigsource.com. This is an indie game development website. Usually they do reviews of indie games and things like that. They also happen to have a forum. And on that forum, a user forum, on that forum, they occasionally do game programming competitions. And in 2008, I participated in one of these game programming competitions. Now, usually a game programming competition will have some sort of time constraint, and it will also usually have some sort of theme. And the theme for the competition that I participated in was that it was a bootleg demake competition. So you're supposed to make a bootleg demake game as your entry for the competition. Now, you may not be familiar with these words, especially in the context of a game programming competition. So I'm going to give just a quick explanation. Let's start with the word demake. A demake is when you remake an existing game, but you do it using technology that is older than the original game was made with. Let me give a couple examples. So for example, you could remake a 3D game as a 2D game, or you could remake a PlayStation 2 game as a Super Nintendo game, or something like that. So you're going to remake the game, but do it using older technology. That's the demake part. The bootleg part is that this remake or demake, it's not really official. So it's not the original people who made the game who are going to be doing it. There's something non-official, non-sanctioned about it. So that could be that you lose some gameplay elements from the original game. It could be that there are, maybe some quality issues or something like that. So that's the bootleg part. So for my entry, in this bootleg demake competition, I chose to make a bootleg demake of The Legend of Zelda on the original NES. But since it's a bootleg and a demake, I chose to remake it rather than using the 8-bit graphics of the original Legend of Zelda. I chose to remake it as an ASCII-based console game, and I chose to name it the Fable of Griselda. I did this again, I mentioned in 2008, so I used C# 2 at the time to make this console application. You can see here, you've probably noticed that the text is not translated correctly. That was intentional. It is a bootleg after all, right? My take on the bootleg part was I kind of envisioned that this game was being developed maybe in some foreign country where copyright laws were not as strongly enforced, and the available translation services were maybe not quite up to snuff. So usually what I did was I took the original English text from The Legend of Zelda, and I would run it through Google Translate, or maybe it was Babelfish at the time, I don't remember, and I'd translate it from, English to French to German to Korean to Chinese, back to English again, and see what I came up with. It was, in case you were wondering, it was really the Asian languages that made that whole process shine, but the others were kind of helpful too. And so you can see here, my entry, it didn't replicate the entire Legend of Zelda game. I just replicated part of the overworld map and the first dungeon, because I didn't want to have to worry too much about copyright laws and stuff like that. And there were some gameplay elements that were different or missing, but you can see from examples like this that most of the screens were a fairly faithful representation of the original Legend of Zelda game, just in ASCII, right? Okay, so let's talk about this experience a little bit. Some of the good things that happened. I had a great time. It was fun. I got to write a game in a programming language of my choice, which was fun. At the time, I was at a point in my software development career where I tended to start more projects than I finished. And this one I actually finished. That was great. You could play all the way through it, and you could beat it and all that sort of stuff. I mentioned this took place on the TigSource forums. There's great community involvement there. For the most part, everybody was super positive and encouraging, stuff like that. That was great. So the game got featured on a couple of websites, which was fun. And nostalgia is always great. So those are some of the good things. Some of the bad things, there were some gameplay issues. I knew that. I was mostly okay with it. I mean, it is a bootleg after all. There were a few parts that weren't quite as finished as I would have liked. We'll actually see a couple of those a little later on. I ended up not having as much control over the fonts and colors that got used as I thought I would. I showed you a couple of screenshots earlier. That's not actually what the game looked like when I was originally developing it. It actually looked a little bit more like this. This is a screen capture that I took while I was developing the game. If you look closely, you'll notice that there are a few gameplay elements that are missing or different in this version. It turns out that, because this was a console-based game, how it actually showed up was dependent on what font the person playing it was using in their terminal, and what colors they had set up, and things like that. And also, fun fact, that depending on what version of Windows you're running, you can get a different font and default colors and things like that. That varies with Windows. And speaking of Windows, one of the other challenges that I had was that it was not a very cross-platform game. It was written, as I mentioned, using C# 2, using the .NET framework, which only runs on Windows. This is before .NET Core and the cross-platform efforts there. Probably could have used the Mono framework, but support wasn't super great, and I didn't try too hard with that. Also, speaking of the .NET framework, I mentioned it does only run on Windows. The idea with the .NET framework was great, that it would just be part of Windows and you would just always have it. But it ended up that you could have the wrong version installed, and that was an issue sometimes for some people who were trying to play Fable of Griselda, that they needed a specific version of the .NET framework. I could have made an installer that checked to make sure you had the right version and installed it if you didn't, and then installed the game. But that seemed like kind of overkill for what we were doing. So those are some of the good things and some of the bad things about this whole experience. And when it was over, I submitted my entry, and it was fun, and it was done. I figured I was done with that code, and I would never look at it again. But since we're talking about it in a presentation, you can probably guess that ended up not being the case. So over the next few years, I thought about Fable of Griselda occasionally, thought about some of the good parts and some of the bad parts. And I started to think about, well, how could it would be super nice if I could address some of those bad parts that happened. If I could address them in a way that made it so that more people could experience the game. That would be fun. I would have liked that. So I got to thinking, what if I remade Fable of Griselda as a web application? Then, depending on browser compatibility and stuff like that, I could have more control over the fonts and colors, which I didn't originally. I could have, it's a way easier distribution model. People don't have to download an executable or an installer or anything like that. So that's good. Again, depending on browser compatibility, it could solve a lot of the cross-platform problems. So I was like, that's an interesting idea. Maybe I could do something with that. But as we all know, if you want a website that is more than just static HTML, basically, if you want more interactivity, which this would need to have, you kind of have to write JavaScript, right? Your browser can run JavaScript. I don't have anything against JavaScript, except when people gush too much about JavaScript. I use JavaScript for work and stuff like that, sometimes for personal projects. But I knew with Fable of Griselda, if I wanted to make it a web application, that there were probably going to have to be some fairly big changes. And as I mentioned, I wrote it in C#. And in case you don't know, C# and JavaScript are not the same programming language. They both use curly braces, and then they start to diverge from there. So the idea of having to make some potentially significant changes to how the game worked in order to port it from a console application to a web application, and having to rewrite all of my C# code and JavaScript code, it really, really didn't excite me. I was like, no, this is not something that I really want to do. So that idea just sort of sat on the back burner for a little while. Until one day, along came something called WebAssembly. Now, I'm not an expert on WebAssembly, so I'm probably going to get some of this wrong. But the main gist of it goes something like this. Your browser can run JavaScript, and we're probably all familiar with JavaScript. Your browser downloads it. It's a text format, theoretically human readable, if it's not too minified and obfuscated. Theoretically, you just download a JavaScript file that some web page uses, and you could look at it and follow along, theoretically. WebAssembly is a binary format. Now you could, but your web browser, it can run JavaScript, and it can also run WebAssembly. Now you could just write some WebAssembly code and load it in your browser and have it run, but really more the intent with WebAssembly is for it to be a compilation target. So I can take code written in a language that my browser does not support, compile it to WebAssembly, and then run that code in my browser. If this whole idea sounds cool to you, there are a lot of languages that have WebAssembly as a compilation target. So if this sounds cool to you, go check to see if your programming language of choice has a WebAssembly compilation target. It turns out that C# does. There have been a few, but the one that I was most interested in is one by Microsoft. It's called Blazor. In 2018, Microsoft released a version. There have been a few different versions of Blazor. The one that they released in 2018 is what what they call server-side Blazor, which is kind of cool. It runs some code on the server, and then using WebSockets sends DOM changes to the browser, which that's kind of cool, but that's not really what I wanted to do for this particular project. In late 2019, Microsoft released what they call client-side Blazor, where I'm going to explain it, but it's just know that it's a little bit of a lie, but it's close enough to the truth for our purposes here. Client-side Blazor allows you to compile C# code to WebAssembly and then run it in the browser. Again, that's a little bit of a lie, but it's close. So in late 2019 and early 2020, I played around with client-side Blazor a little bit and was like, oh, this is cool. Lets me write C# code and run it in the browser. That combined with my other thought of, oh, wouldn't it be cool to rewrite or port my Fable of Griselda code, which was written in C#, to run as a web application? Maybe this whole thing could actually work, right? Of course, at this point, the code is about 12 years old. I hadn't changed it or even really touched it since I finished the original coding, the original game programming competition. And, I had no test coverage. I was going to need to be making significant changes to this code, probably. Usually in this sort of situation, I tend to have this sort of reaction, right? Like, no, this is not going to go well. Not excited about this. Again, 12-year-old code, completely different input-output mechanism, completely different storage mechanism. In the original code for all the maps, all the screens, all the individual screens, those were text files in a directory that I would read through. Browsers do not let you just read random, all the files in a random directory on your file system. That would be a bad thing. This is a completely different hosting model. And again, as I mentioned, there was no test coverage. This sounds like a recipe for disaster. What in the world is our heroic code going to do to overcome these challenges? We'll get to that, but first, a message from our sponsor. And by a message from our sponsor, I mean, let's talk about software architecture for a minute. Let's start by talking about what's called a layered architecture, sometimes a tiered architecture or n-tiered architecture. Now we could get into, for some people and in some contexts, it's really important, the difference between a layer and a tier. For the purposes of our conversation here, I don't really care about the difference. So this is a type of architecture that was very popular several years ago. It's maybe a little less popular now. But the idea, in the generic version is called an n-tiered or n-layered architecture. A very common implementation was to have 3 layers or tiers. You could have more or less, but a common implementation had 3. And with a 3-layered or tiered architecture, you would have one chunk of your code that had to deal with reading and writing data. That's your data layer, right? You had another chunk of code that deals with how to display your data. That's the presentation layer. And you had a chunk of code in the middle that was your business logic, right? That did all the rest of the stuff. And one of the key components of this type of architecture is that you could have dependencies, higher layer tiers or layers could have dependencies on lower layer tiers. So for example, your business layer can have dependencies on your data layer, which kind of makes sense. Your business layer can know something about how data is stored and retrieved. That kind of makes sense. It also kind of makes sense when you think of like your data layer. It's not going to know about your presentation layer. The dependencies go down, not up, right? So your data layer is not going to know about your presentation layer. You're not going to have buttons and click event handlers and stuff in your data layer, right? So one of the challenges that can come up with this type of architecture is because you have all these dependencies going down, and you often have this sort of data layer at as the bottom layer, what happens if you change how you store your data? Another problem that can sometimes occur with this type of architecture is because higher layers can depend on things like data structures from lower layers. What happens when those data structures start getting used in higher layers, right? This is not a guaranteed problem with this type of architecture, but it can happen. What can happen is that how you store your data, things from the data layer, can get coupled to how you display your data, stuff in the presentation layer. And as we know, when you have two pieces of code that are highly coupled, it's hard to change one of those pieces of code without changing the other. And since these dependencies go through all the layers of this type of architecture, you can end up with all the layers of your architecture tightly coupled together, meaning that they're difficult to change. It's not a great place to be. Let's contrast that with hexagonal architecture. It's in the title of the presentation. We should probably talk about it at some point, right? Hexagonal architecture, it's also called ports and adapters architecture, comes to us from Alistair Cockburn, who's one of the original Agile Manifesto authors. Smart guy. This particular image comes from his website. I think it's from like the late 1990s or something. It's a little bit hard to, for me at least anyway, a little bit hard to understand from this particular picture. So I hope neither you nor Alistair will mind. I made my own image. I do not profess to be an expert on hexagonal architecture, so I'm not going to go into all the details, but I'll give you hopefully sort of an overview gist of the idea. So with hexagonal architecture, there is a chunk of your code that is your core business logic, right? And then there are other pieces of your code that you can use to drive that core business logic. So on one side, you can have different types of drivers. For example, you can have UI drivers, and you can have different UI drivers. Like you could have a console UI driver or a GUI desktop type UI driver or some sort of web driver. You could also have programmatic drivers. Now, for the programmatic drivers, you could think of automated tests as one type of programmatic driver. You could think of like a web API as another type of programmatic driver. Then on the other side, you have, so these are ways that the outside world can interact with your core business logic. And then there are ways that your core business logic can interact with other parts of the world, right? Here I have data storage mechanisms, but you could also think of calling web APIs or publishing messages to a message broker or something like that. The idea here is that you can mix and match both the drivers and the external interactions, like data storage and things like that. You can mix and match those however you want, and your core business logic doesn't need to change. Your core business logic doesn't need to change if it's being driven from a console application or a GUI application. It doesn't need to change if you're storing data to a database or if you're storing data to an in-memory storage of some kind. Let's also talk for just a minute about something called onion architecture. There are a lot of parallels between onion architecture and hexagonal architecture. Onion architecture comes to us from Jeffrey Palermo. Again, I'm not an expert on onion architecture, so I'm not going to go into super detail. I'm going to just kind of give you a high-level overview. I don't totally love this image. It's a little bit better than the one from Alistair's website, but I'm going to make my own here. Oh, and since we are talking about onion architecture, please feel free to insert the obligatory Shrek reference here, you know, just like Ogre's architectures have layers. The idea with onion architecture is that you have in the center, you have some core business logic. Again, in Jeffrey Palermo's image, he had more layers, and then he details those. For our discussion here, I'm just going to sort of clump it all together into business logic. That goes in the core, and then around the outside, you have details. What are some examples of those details? Some examples could include things like what web technology you're using. That's a detail. What UI framework you're using. That's also a detail. Whether or not your code is being driven from some sort of testing harness. That's a detail. I shouldn't have to recompile my code if I want to run it under test, or I shouldn't have to run my code in some special test mode or anything like that. Some other possible details are infrastructure. How's my code being run? Is it being run as a console application? Is it being run as a web application? Just hypothetically speaking. What sort of database is it using? Is it using a database at all? How is it persisting its data? How is it being hosted? Is it being hosted on-prem or in the cloud or something like that? All of these are details. That's not to say they aren't important. Details are very important, but they're not core to the business logic of your code, right? And so consequently, dependencies never go out. Your core business logic doesn't depend on these details. The details can depend on your core business logic, but not the other way around. Okay, that discussion about a couple of different architectures. Let's get back to our heroic code. When we left it, we were trying to figure out how we were going to overcome this monumental challenge of porting this 12-year-old code running as a console application to a web application. How could we ever possibly overcome these challenges? Well, actually, if you go to fableofgriselda.com right now, you can go see it. It actually mostly works. Now you might be saying to yourself, okay, well, that's cool, it works, but what had to happen in order for that to work? It turns out that it actually ended up being easier than I thought it was going to be. There were some parts of it that actually seemed a little bit too easy. Let me explain to you what I mean. After I finished converting most of it to a web application, I wrote some code that would take the old version of a file and the new version of a file and compare them. I did ignore, the code that I wrote did ignore like a few things like white space at the beginning and ending files. I didn't want to have to, deal with tab changes or whatever. I also changed, when I ported the code, I changed what namespace I was using. And if you're not familiar with C#, a namespace is just a way to group classes together. And I changed which namespace I was using between the console version and the web version. So I ignored some stuff related to that. But other than that, this code, it looked for files that were identical, again, ignoring white space at the beginning and ending of lines, between the old file and the new file. And the main part of this table that we're going to look at is this percent the same. You can look at the others too, but this is the main column we're going to focus on. And you'll probably notice by looking at this that these different files fall into kind of three categories. You could make more, but we'll call it three categories for now. There's one category of files that are either exactly the same or almost exactly the same, right? And exactly where we draw the line between these groups isn't super important, but the fact that these three groups exist is important. So there's a group of files that you can see almost are exactly the same. There's another group of files that there's a lot of stuff the same, but then there's some stuff that's different too. And then there's also another group of files that are almost completely different or didn't exist in one version of the code or the other. So let's look at some of these different groups of files in a little bit more detail. So let's look at this game tiles file. Fable of Griselda is a tile-based game, and so this is the list of all the possible tiles that can show up on the screen at any given time. And you can see up here at the beginning, I did change the access modifier. I didn't really need to do that. I made it public. Didn't really need to do that, but I did. And I changed some namespace stuff. And other than that, the rest of the file is identical. It's exactly the same, right? Now you might be saying to yourself, okay, well this is nice, but this is a fairly trivial example. Let's look at a little more in-depth, a little more complicated example. Let's look at this file, abstract enemies. So this is the base class for all of the enemies in the whole game. This handles some common logic like moving around the map, decrementing health when enemies get attacked, that kind of stuff. You can see up here there are some namespace changes, and then the rest of the file is exactly the same. So these are a couple of examples from that first category of files that we were talking about. Let's look at some examples from that middle category. Let's look at this example. This is the map loader file. As you might be able to guess, this has to do with loading maps. Each of those, as I mentioned before, each of the maps or screens. I called them maps, but you can think of it as a screen. Those were, in the original code, those were text files on disk in a random directory. And as I mentioned earlier, that doesn't work with a web browser. Web browsers don't let you just look at a random directory on your file system and read all the files in it. So you can see that there are some differences here that have to do with passing in paths and things like that. There's also on line 86 on the left. There are some changes from a stream reader to on 85 on the right, a string reader. That had to do with how I read them in differently, how I read those in those text files differently. That's what most of these changes are, is dealing with that change from stream reader to string reader. But there's also some of these where I don't have to have a path anymore because I'm not reading the files off of disk. So this is one of an example from that middle category. Let's look at another example from that middle category. So in the original code, I used sort of a state model, or you can think of it as a state pattern, or you can think of it as a strategy pattern. They're very similar. To handle the different phases of the game. So like the introduction screen is one state. The main game where you're moving around and stuff and attacking enemies and stuff, that is another state. And then there are a few others. This is the main state. I call it main model for some reason. I don't know why I did that. But this is the main state of the game where the game is accepting user input and moving the character around. You can attack enemies and pick up items, all that sort of stuff. And you can see there's a lot here that is the same. There are some changes though. A couple different types of changes. This one is actually, I switched to use a new language feature that wasn't available at the time when I wrote the original code. So here I'm actually using some newer stuff. So that's one of the types of changes. Here, this is using a settings class. In the original code, I wrote, I had some settings like where the player starts at the beginning of the game and how much life they start with and stuff like that. I had that stored in a settings file on disk that I would then read at startup time. So that way I could change it easily. Ends up I never needed that extra flexibility. So when I ported it to a web application, then I just hard-coded all of those values. And so there were some changes with that. You can also see, we already talked about the map loader code. That gets used here in this main model state. And because it doesn't have to use paths and things like that, then its usage changed. So that's another type of change here. This one's interesting. You'll notice on the left, there's all this console key dot something. So up arrow, down arrow, blah, 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 blah. That console key thing, it's actually an enum. That console key enum is very specific to a console application. So it's a thing that console applications use and web applications don't. And so you can see that was a part of this piece of code that I had to change. I made it more generic so that rather than relying on this console application specific thing, I changed it to just use strings. So this is an interesting change. This last one in this file that I want to talk about, this is actually one of my favorite changes to talk about because you can see what was going on what was happening when I wrote this code. I mentioned that usually in game programming competitions there's a time constraint, and this one had one, and I ended up running into it. And this piece of code right here is a direct example of that. I was getting to the point where I needed the game to be completable and you couldn't actually win the game, but I was running up against that deadline, that time constraint, And so right here in the middle of my game logic, I said, hey, when you damage an enemy, was that enemy the end boss? And did the end boss just die? If so, go ahead and clear the screen and print out a message to the user and uh, exit the process. You can actually see here, I wrote it right out. It said, sorry, I didn't come up with a cooler ending. I ran out of time. And as you can see, this is a part of the code that I had to change because you can't just write stuff out to the console like this in a web application, expect your user to see it, and then exit the process. That does not work. So these are a couple of examples from that middle group of files that I talked about. Now, and then is also that last category where things were almost completely different. Here's one example of that. This is the display class. This has all to do with how things are actually displayed to the screen, either to the console in the original code or to a web page in the new code. And as you can see, there are a couple of lines that are the same, but it's almost completely different here. You can see over here on the left, on the diff, that the two files are almost completely different. So overall, though, I considered this a win. There were a lot of files that just came, as you saw, came almost straight over, almost completely untouched. There was a set of files that came over with some changes, and then there were some files that were almost completely different. The encouraging thing for me was that those files that were almost completely different usually had to do with how things were displayed or how things were stored, not the actual core game logic itself. So, what made this possible? There are a couple of possible reasons that we could think of. One is that Microsoft just solved everything, right? They wrote a tool that let you take your console application code and recompile it, and suddenly it's a web application, right? Well, we saw that this wasn't the case because I had to change some of the code, right? So it did not just come straight over. There were some changes that needed to be made. This isn't to discount the things that Microsoft did, though, like being able to compile C# to WebAssembly, being able to compile old JavaScript with old C# with a new C# compiler. To Microsoft's credit, and sometimes to its detriment, it focuses a lot on backwards compatibility, and this is a time when that helped me, right? I could take this C#2 code and expect it, at least from a language feature perspective, to still compile using a modern C# compiler. Obviously didn't compile from a framework feature perspective, but from a language feature perspective, it did. So, this was definitely part of the solution, but it wasn't the whole solution, right? So another possible explanation is that I'm just a super awesome, amazing developer, and I'm super smart, and there's something innate in my abilities that made it so that this all just worked. No, that is not true. I figure I'm an average coder in my coding abilities, but there's nothing super special about my capabilities as a coder. So that leaves us with, there must be something about how the code was written that caused this thing that we observed, right? That some of the code ported over directly. So I believe that it was because, in most cases, not in all cases, as we saw, that the original Fable of Griselda code followed this sort of architectural pattern. Now here I've drawn it as an onion architecture. I think it fits a little bit better than the hexagonal architecture, but you could draw it as the hexagonal architecture as well. This idea of having a core business logic code and then details on the outside. So, for example, the first couple of files that we looked at, that game tiles file and abstract enemy, where they were virtually unchanged, essentially unchanged, those are very definitely core business logic, right? And we saw that they didn't have to have essentially any changes. We also looked at the main model file, or that's the main state where the main part of the game is working, right? And if you'll remember, that one according to my code, it was about 64% the same. So a lot of it was the same, but some of it had to change. I would argue that most of the changes that happened there had to do with when the code in that file deviated from this architectural pattern, stuff that we saw like with console key stuff and putting stuff out to the console and exiting the process, things like that. So I would argue that that main model file should go in this core business logic, but that it violated this sort of architectural pattern, and that's why it had to change. We also had a couple of examples, such as settings. We didn't actually look at the file for that, but we talked about it, and the display file, which are very clearly should go in the details category. And you can see those had to change significantly. We also had one other example, you may remember, of that map loader file, which was kind of in the middle, right? So should it go in that core business logic part, or should it go in the detail part? I would argue that the fact that there are maps or screens in the game that's pretty fundamental to how the game works, and so that part should go in should actually be in the core business logic. The necessity to load those screens or maps, I would argue, is also probably in the core business logic. What I would argue happened here is that there probably needed to be another abstraction. Like there needed to be a way to parse and load these files that is separate from how they actually get loaded from disk or from wherever they're actually stored. So I'm guessing that's why this one had, there was a lot the same, but there were also still some changes. So my overall assertion is that most of the code from Fable of Griselda was relatively easy to port because it followed this core business logic plus other stuff as details architectural pattern. As we saw, it didn't follow it perfectly, and I assert that the places where it didn't follow that type of architectural pattern, that's where we had to do more changes. I would also assert that one of the signs of a good architecture, however you want to define good architecture, is that if you make some change in how your software is used, like porting it from a console application to a web application, that if it does have good architecture, the core parts of how that software work shouldn't need to change. The details will, but the core part shouldn't. Yeah, so I've heard that good presentations should have some sort of call to action. Now that you've listened to me talk for a while, what should you go do based on this presumably new knowledge that you have? So here's my obligatory call to action, but I'm lazy. So rather than giving you one single call to action, I'm going to give you a list of potential things that you could do, and I'm going to let you choose. So one of the things you could do after listening to this presentation is you could go learn more about hexagonal architecture. As I mentioned, I'm not an expert in hexagonal architecture, but Alistair Coburn is, and he wrote a great article about it, so you can go read about it. I also mentioned I'm not an expert on onion architecture, but Jeffrey Palermo is, and he wrote I think a 4-part series all about onion architecture. You can go read it and learn more about it. I mentioned that there are a lot of similarities between hexagonal architecture and onion architecture. There's some differences too. You can go learn more about some of those similarities and differences. I found one article here that I liked that talks about a lot of the similarities. There are probably others as well. You can go find some and learn about some of those similarities and differences. There's another architecture called the clean architecture. It comes to us from Robert Martin, Uncle Bob. It's part of his Clean Coder series. You could go read it. It has a lot of similarities to hexagonal architecture and onion architecture, but it has some differences too. He wrote a whole book about it. You could go read that. I provided a link here. It's an Amazon link. Don't feel obligated to buy it from Amazon if you don't want to, but I wanted to make sure you could know if you got the right book or not. So you can go learn about that as a possible option. In this presentation, we looked at some of the code from Fable of Griselda and analyzed it from the perspective of how well it followed this type of architectural pattern. You could go do that in some code that you're more familiar with. Maybe that's side project code, maybe it's school project, maybe it's the code that you work in every day. You go look at it and say, how well does this follow this type of architecture? Maybe you want to experiment with this type. You're not as familiar with this type of architecture and you want to experiment with it. That would be a great thing to do. If your next school project or work code or whatever, if that works well, go ahead and do it there and do some experimentation. If not, maybe you could do some sort of side project or something where you try writing some code using this type of architectural pattern and see how it works for you. I mentioned that I work at a company called Immersion. We have what we call a guest mobber program. We do mob programming. It's kind of like pair programming, but rather than having two people work together on a piece of code, we have the whole team work on a piece of code. And we have a program where you can sign up to come and work with us for a couple hours this way. So if you're interested in pair or mob programming or test-driven development or just hanging out and coding for a couple hours with people who care about how their code is, care and like to talk about how their code is architected, feel free to sign up for our guest mobber program. And last, but hopefully not least, you can go play Fable of Griselda. Because it will probably work on your device. And you can go and enjoy it for the weird wonder of nostalgia that it is. And with that, thank you for attending. Again, here's a link to the slides as well as a QR code. Thank you for attending this session. I hope you have a great day and a great rest of your conference.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.